Hello everybody. So today we are mainly concentrating on the geometry or structures of molecules with the help of Vesper-Therian hybridization, and we are mainly concentrating on the structure of molecule which has on trigonal bipyramidal structure. We mainly concentrate on the trigonal bipyramidal structure with the help of hybridization and Vesper-Theories. It is start. Today we are just discussing how to predict the geometry or structures of molecules, and I am going to discuss its applications on the trigonal bipyramidal geometry. So, how to determine the structure of geometry of the molecule? So, generally it is effectively explained by two theories. One is Vesper theory. So what is Vesper theory? That is valence electron pair repulsion theory. And the second one is hybridization. So we can determine the geometry or structure of molecules based on two theories, Vesper theory and hybridization. So these two theories are actually independent theories, but for our convenience, we are combining both of them. So they are actually the independent theories, but for our convenience, we combine both of them and let us discuss the structures. So first of all, what is the basic difference between the words geometry and structure? So when should we use the word geometry and when should we use the word structure? So what we say is geometry or structure, it is generally decided by the number of electron pairs. Electron pairs present in the valence shell of central atom. Number of electron pairs in the valence shell of central atom is going to decide the geometry or structure of the molecule. So in the valence shell of central atom, if you have 2 electron pairs, it will be linear. 3 electron pairs, trigonal planar. 4 electron pairs, tetrahedral. 5 electron pairs, trigonal bipyramidal. 6 electron pairs, octahedral. 7 electron pairs, pentagonal bipyramidal. So we say that the geometry of structure is decided by the number of electron pairs. So this electron pairs we classify into two types. First one is lone pair and the second one is bonded pair. So what is the difference between the lone pair and bonded pair? Lone pair electrons. Lone pair, we say that these are non-bonding electron pairs present in the valence shell of central atom. Means these electron pairs, they do not involve in bonding. And the second one is bonded pairs. So the electron pairs which are involved in bonding, we call them as bonded pairs. And this bonded pairs, again we take it as two types. One is sigma bonded pairs. Sigma bonded pairs, so they always form sigma bonds. Pi bonded pairs, they form pi bonds. Now, how to explain the structure? By using the Vesper-Therian hybridization. So, lone pairs and sigma bonded pairs. Lone pairs and sigma bonded pairs, they always occupy hybrid orbitals. They always occupy hybrid orbitals, therefore they can determine the geometry or structure of the molecule. Okay, and then the pi bonded pairs. Pi bonded pairs, they are always formed with unhybridized or pure orbitals. Pi bonds, they are formed with unhybridized or pure orbitals, so they cannot influence the structure of the molecule. They cannot change the structure, but they can change the bond angle of the molecule. Now, what is the exact difference between the words geometry and structure? So, when should we use the word geometry and when should we use the word structure? So, geometry, it includes all the electron pairs in the valence shell of center atom. All the electron pairs in the valence shell. So, all the electron pairs means it includes the lone pairs and bonded pairs. Structure, it includes only the bonded pairs. That too, only the sigma bonded pairs. Structure, it is determined with bonded pairs. Geometry, we determine with both lone pairs and bonded pairs. So let us see this in the example of water molecule. So this is the structure of water molecule and it is sp3 hybridized molecule. In this we have two bonded pairs and two lone pairs. So these are non-bonded electron pairs, so we call them as lone pairs. So the water molecule, it has two lone pairs and two bonded pairs. So on the whole, number of electron pairs in the molecule are 4. So if the number of electron pairs in the molecule are 4, the geometry must be tetrahedral. It must be tetrahedral. So we say that geometry is tetrahedral here. But what is the structure of the molecule? That is, structure, it includes only the bonded pairs. Only the bonded pairs. Therefore, when we neglect this lone pairs, it appears like an angular molecule. Angular molecule. So the structure of the molecule is angular or V-shaped. Geometry includes both bonded and lone pairs. So we say that it is tetrahedral. Structure, it includes only bonded pairs. So we say that it is angular or V-shaped. And the application of these two theories on trigonal bipyramidal geometry. Trigonal bipyramid. So why we are specifically taking this trigonal bipyramidal geometry? Because of its difference in hybridization. So if you take trigonal bipyramidal geometry, it has 5 electron pairs. 5 electron pairs. So hybridization would be sp3d. So sp3 dehybridization, we are writing it as sp2 plus pd hybridization. Means the hybrid orbitals, whatever the 5 hybrid orbitals we get over here, they won't have the symmetrical distribution of sp and d characters. The distribution of sp and d characters is not uniform among all the orbitals. If you see this, these are called as equatorial orbitals. And these equatorial orbitals, they are formed with sp2 hybridization. And these orbitals, we call them as apical or axial orbitals. And they are formed with pd hybridization. That's why sp3 dehybridization, we write it as sp2 plus pd. So in the apical orbitals, there is no s character. There is no s character. And in the equatorial orbitals, there is no d character. So since the distribution of sp-d characters is not uniform, we call this geometry as an asymmetric geometry. And when we see the bond angles in the molecule, bond angles between the two apical bonds, the bond angle is 180 degrees. Between the two equatorial bonds, the bond angle is 120 degrees. And when we take an apical bond and equatorial bond, the bond angle would be 90 degrees. So this is the bond angle in the molecule. Now, whenever we have lone pairs in the molecule, as already we have discussed, lone pairs, they are going to cause the distortion. Lone pairs will change the geometry of the molecule. We call it as distortion. Lone pairs will cause the distortion. Multiple bonds, they cannot change the structure, but they can change the bond angle. That's why we have some specific positions for lone pairs, multiple bonds and electronegative atoms. So how to determine the position of lone pairs, multiple bonds, electronegative atoms? So we can explain their position with Bent's rules. So what is the first rule? It says that lone pairs will always occupy the hybrid orbitals with more s character. Lone pairs occupy the hybrid orbitals with more s character. So what happens if the s character is more? Lone pair, it is attracted by the nucleus of only the central atom. Only the nucleus of central atom attracts the lone pair. So if the s character is more, for that hybrid orbital, this lone pair can easily penetrate towards the nucleus. It can easily penetrate towards the nucleus, hence it is more stabilized by the nucleus. So, when we apply this rule to the trigonal bipyramidal geometry, lone pairs must always occupy equatorial positions. When we apply the first Bent's rule, so lone pairs will always occupy equatorial positions in trigonal bipyramidal geometry, because these are the positions where we have s character. And the second one is multiple bonds. So where should we place these multiple bonds? Multiple bonds, that is double or triple bond, they are always formed after the formation of sigma bond. Double or triple bonds, we call them as multiple bonds, and they are always formed after sigma bond. So this multiple bonds always prefer the sigma bond which is formed with the hybrid orbital of more s character. They prefer the sigma bond formed with hybrid orbital of more s character. So what is the reason for that? When the s character is more, the covalency will increase. The covalent character of the bond will increase, and the bond length will decrease. Bond length decreases, because formation of double or triple bonds will always decrease the bond length as they are formed by the lateral overlap of orbitals. Formation of double or triple bonds, they always decrease the bond length as they are formed by the lateral overlap, and this lateral overlap is more effective when the s character is low. So when we apply this rule to the trigonal bipyramidal geometry, again the multiple bonds, that is double or triple bonds, they have to occupy the equatorial positions. And the position of more electronegative atoms. What is an electronegative atom? Which has more electron density. Which has more electron density, or which withdraws more electron density towards itself, we call it as electronegative atom. And this electronegative atom always requires the hybrid orbital with less s character or more p character. So why it prefers the hybrid orbital with less s character? When the s character is more, even the central atom can But electronegative atom has to take more of electron density from the central atom. So that is possible only when S character is less. And when we apply this rule to the trigonal bipyramidal geometry, more electronegative atoms, they always occupy apical positions. Because in these apical positions, the S character is almost negligible. So there are more electronegative atoms occupy the apical positions. Let us apply this Bend's rules in the trigonal bipyramidal geometry. So first I am taking the example of PCl5. So in this the central atom is phosphorus. It is fifth group element, so it has 5 valence electrons. And each of the valence electron of phosphorus, it forms a bond with chlorine. So we have 5 sigma bonds and 0 lone pairs. So the total number of electron pairs with the molecule are 5. And when the number of electron pairs are 5, the geometry will be trigonal bipyramidal. So here, when the electron pairs are 5, geometry will be trigonal bipyramid. So here we get trigonal bipyramidal geometry. And what would be the structure? Here there are no lone pairs. Therefore, the geometry or the structure of the molecule is the same. That is trigonal bipyramidal. Now, when I take PCl3F2, so central atom is phosphorus, fifth group element, so we take 5 valence electrons. 3 electrons, they form sigma bonds with chlorine. 2 electrons, they form sigma bonds with fluorine. So total number of electron pairs, they are 5. Total number of electron pairs are 5. So hybridization is sp3d. Geometry or structure, since we do not have any lone pairs, so we say that geometry or structure is the same, trigonal bipyramid. But how does this molecule differ from PCl5? So here we have 2 fluorine atoms. 2 fluorine atoms which are more electronegative than chlorine. So where should we place this fluorine atom? That is according to the Bend's rule. Electronegative atoms occupy the hybrid orbitals with less S character. That is apical positions. They occupy apical positions. Now, when we take the next molecule, SF4, here the central atom is sulfur. Sulfur, which is the 6th group element, so we take 6 valence electrons. So 4 electrons form sigma bonds with fluorine atoms, and the remaining 2 electrons, it becomes the lone pair. So in this molecule, we have 4 bonded pairs plus 1 lone pair. So on the whole, total electron pairs are 5. Hybridization is sp3d. Geometry, trigonal bipyramid. But what is the difference from PCl5? This molecule, it is having lone pair. And the presence of lone pair will always distort the structure. Presence of lone pair distorts the structure. Therefore, instead of trigonal bipyramidal geometry, the structure of the molecule becomes distorted tetrahedron. Distorted tetrahedron or seesaw structure. And what should be the position of that lone pair? Again we should apply the Benz rule. So Benz rule says that lone pair should occupy the hybrid orbital with more s character. That is the equatorial position. Equatorial position. So here the lone pair is present in equatorial position. So the geometry of molecule is trigonal bipyramid because we consider lone pair and all the bonded pairs. But when we consider the structure, we should ignore this lone pair. So when we ignore this lone pair, molecule appears to be tetrahedral, distorted tetrahedral. And the other example, that is XeOF2. So here xenon is the central atom which belongs to 0 group and it has 8 valence electrons. Out of 8 valence electrons, 2 electrons are used in forming double bond with oxygen, 2 electrons for forming sigma bonds with fluorine, and the remaining 4 electrons they become 2 lone pairs. So here we have multiple bond, we have lone pairs. So what should be the position and what should be the geometry and structure? So we have 3 sigma bonded pairs. We have already discussed that pi bonded pair will not influence the structure. So we won't consider this pi bond, we include only this sigma bond. So 3 sigma bonded pairs plus 2 lone pairs. So total electron pairs in the molecule are 5. So hybridization, sp3d, geometry, trigonal bipyramid. But what is the structure? Because of lone pairs which would cause a distortion, molecule it has the structure of P shape. Molecule has P shape as the structure because of the lone pairs. So here we have double bond and also the lone pairs. So where should we place them? Again we should apply the Benz rule. So Benz rule says that multiple bonds must occupy equatorial positions in trigonal bipyramidal geometry as S character is more over here. Similarly, lone pair also occupy the hybrid orbitals with more S character, that is equatorial position. So geometry of the molecule, it is trigonal bipyramid when we include all the bonded pairs and lone pairs. Structure, it is T shape. When we ignore this lone pairs, molecule becomes T shape. So the structure becomes T shape. And the next example is XeF2. So xenon, it is 0 group, 8 valence electrons. 2 electrons form sigma bonds with 2 fluorine atoms, and the remaining 6 electrons they form 3 lone pairs. So we have 2 bonded pairs, 3 lone pairs, that is 5 electron pairs. Hybridization is sp3d, geometry it is trigonal bipyramid. But what would be the structure? Because of the lone pairs, again distortion occurs. Therefore, structure of the molecule will be linear. And what are the positions of lone pairs? Again, when we apply the Benz rule, they occupy the equatorial positions as the S character is more in the equatorial position. So, what are the possibilities of questions we can have over here? So, first one is they generally give you the set of examples. And they'll ask you either the geometry or structure of molecule. So we have seen several examples of PCl5, PCl3F2, SF4, XeOF2 and XeF2. So where we have to determine either the geometry or the structure of the molecule. And the second possibility is they'll ask you the bond activity. the structures of the molecules. So that we have seen in the earlier examples. So based on the number of lone pairs, we are able to decide the structures. So 0 lone pairs, we get trigonal bipyramidal structure. 1 lone pair, it is distorted tetrahedron or seesaw structure. 2 lone pairs, it is T-shape. 3 lone pairs, it is linear. And the other possibility of questions is the position of atoms and the bond angles. So if I take the example of HCO2 F2, so this is the structure of the molecule. And here what is the question we can get? That is bond angle between oxygen atoms. So here oxygen atoms, they are occupying the equatorial positions, and between the equatorial positions, the approximate bond angle is 120 degrees. So we can say that the approximate bond angle between oxygen atoms is 120 degrees, as the oxygen atoms occupy equatorial positions. And the second one, I3 minus. I3 minus, it has 3 lone pairs, so the structure of the molecule is linear. So in this, what are the different type of questions we can get? First one is bond angle between lone pairs. So the lone pairs, they occupy equatorial positions. Therefore, the approximate bond angle is 120 degrees. Approximate bond angle 120. And what will be the bond angle between bonded pairs? Bonded pairs. So we have the bonded pairs only in apical positions. Only in apical positions. Therefore, the bond angle will be around 180 degrees. And HCF2. So this is also the linear molecule. And here, what is the bond angle between bonded pairs? So bonded pairs, we have in apical positions. So the approximate bond angle here will be 180 degrees. So mainly they'll ask you the structure of the molecule, and they'll ask you the position of atoms in this geometry, and they'll ask you the approximate bond angles. The geometry